welcome back. So, we were discussing the Clep review. The first part covered all the way up to number 45, so we're going to start on number 46. On question number 46, it is asking you to find theta, that is between 0 and pi over 2. It tells you that 10 sine theta equals z, which also means that the sine of theta equals z over 10. And remember that this is opposite over hypotenuse. So on our triangle over here, we're doing opposite from theta is z over the hypotenuse of 10. Alright, so, and it wants us to find tangent. Well, in order to find tangent, we need opposite over adjacent. So I've got to figure out this side. So the way I approached it was I decided, okay, well, if this is x, we can say that we have x squared plus z squared equals 10 squared, or x squared plus z squared equals 100. Subtracting z to the other side, I get x squared equals 100 minus z squared. And then to get x by itself, I'm going to square root both sides. So I get x equals the square root of 100 minus z squared, which is this side over here. Alright, and as we talk about tangent, remember that tangent is the opposite over adjacent. So from here, opposite would be z. Adjacent would be the square root of 100 minus z squared. Alright, moving on to question number 47. On 47, first of all, they give you a picture of a linear function. Just the first quadrant because it's a real life situation. We have this line drawn like this, and they give you the point. On this side, this is the point $0.12. And on this side, they give you the point 120 and $0. Alright, so the bottom is the number of units, and of course side is money. Alright, so first of all, it wants to know, based on the model, how many dollars would the convenience store expect to earn from its sales of product X in a week when the price is $5. So first of all, we need to write a line equation for this. So we have y equals the slope. Now, the slope would be down 12, so negative 12, and over 120. X, and then plus, and our y-intercept is right here, which is plus 12. Now we can simplify this, right? This is actually y equals negative 1 over 10x plus 12. So this is our line equation. Now, it's telling you that it's going to cost $5. The cost is our y value, so we're going to plug in 5 for y. Alright, and we can start by clearing the fraction. So if I multiply everything by 10 is one way to do it. Of course, you could just subtract 12. That's another way to do it. If I multiply by 10, I get 50 equals negative x plus 120. Subtracting 120 to this side, I have negative 70 equals negative x, or x equals positive 70. Now that's telling you how many units they sold at $5, right? That's 70 units at $5. But the question wanted to know how much would they be earning. So we actually have to multiply those. Take our 70 units times $5 to find out what they're making. And they are making $350. Alright, let's talk about number 48. Now 48, there's a couple different ways you can approach it. So let's talk about that. In number 48, they give you this picture that looks like this. And it crosses at 2 and 2 here, right? And it says this is defined by f of x equals the square root of 2x plus 4. So you can see why it moved to the left too. if, and they want to know if the inverse, what is the value of the inverse at 2? So we can graph the inverse, or we can do it algebraically. First, if we graph it. If we graph it, remember that it reflects. This point is the point negative 2, 0, which means when we graph it, it's actually the point 0, negative 2. So it's this one when it's an inverse, right? This point right here is the point 0, 2. So on the inverse, it becomes the point 2, 0. So we actually get this graph that starts here, crosses, and goes up that way. Remember that an inverse always crosses through this diagonal, right? That's what it's symmetrical from. Okay, so if that's the case, if I'm looking for where x is 2, right, what is the value at x equals 2? Well, right here where x is 2, what's our y value? It is 0. Now let's do it algebraically also. Algebraically, remember to find the inverse, you first switch x and y around. So x equals the square root of 2y plus 4. Then we're going to square both sides, so x squared equals 2y plus 4. Subtracting 4 to the other side, we get x squared minus 4 equals 2y. And then if we divide by 2, this is our inverse equation. So now, if I want to know what it is when x is 2, I'm going to plug 2 in for x. And I have 2 squared minus 4 over 2 equals 0. So no matter which way you do it, graphing or algebraically, you still get 0. All right, number 49. On number 49, there are actually 2 triangles that are involved here. So let's see if I can draw this. We have the Statue of Liberty and its base. And of course, it comes way out here. And so we really have 2 triangles. We have one that goes from here to here, and we have a second larger triangle that goes from here to here. Alright, so the information they give us is that this piece is 47, this piece is 46. We also know that this is what we're trying to find. This is theta. And what they want to know is which of the following best expresses the angle for theta in terms of d. And d is the distance from the statue to where your point of view is. Okay? So what we really want to do is we want to take the big triangle and subtract the bottom triangle. Right? So we're going to take the big triangle and minus the bottom triangle. That's going to give us the top triangle and what we want to do with it. Alright, so first let's talk about the different tangents. I went ahead and named for the big one, I named this angle my beta. And so really I have the tangent of beta equals the opposite, which is both of these added together, which is 93, over the adjacent, which is d. My second one for the smaller triangle, or the bottom triangle, that is the tangent. And if I just do this bottom one, let's call that x, right, equals 47 over d. Opposite over adjacent. Okay? Now, first of all, we want it in terms of d, so we need to change this around a little bit. We talked about the fact that any time we're solving for an angle, we use tangent inverse, or the other word for that is arctangent. So this can be rewritten as the tangent inverse of 93 over d equals my angle. This one can be rewritten as the tangent inverse of 47 over d equals x. And the idea is we're taking our beta angle and subtracting our x angle to get our theta angle. So that means we're taking this first one, and whether we say tangent inverse or this is the same as arctan, right? Taking this one and subtracting that one. So we have the tangent inverse of 93 over d minus the tangent inverse, or arctan, of 47 over d. All right, let's talk about number 50. On number 50, the value log of 1,000 or 1,732 is between what two integers? Well, in order to figure that out, first of all, remember when there's no base for log, the base is 10, right? And so really we have two options. When you talk about base 10, you go 10, there's 100, there's 1,000, and there's 10,000, right? This is 10 to the first, 10 to the second, 10 to the third, and 10 to the fourth. When you're writing a log, we know that 10 to the third is equal to 1,000 when you do the inverse of this, right? And 10 to the fourth is equal to 10,000. So in this case, 1,732 falls between these. So it is between the integers 3 and 4. All right, so the real trick is remembering that the base, if there's nothing written there, it's a base of 10. All right, number 51. In number 51, it says, which of the following is an equation for the vertical asymptote of the graph? Y equals secant of 6x minus pi. So, first of all, let's look for our period. We need to talk about that. So the period, of course, is 2 pi divided by b, or 6, which means our period is pi over 3. All right? Then we also need to discuss the phase shift, which happens here. Your phase shift, 6x minus pi, is equal to 0. So 6x equals pi, which means x equals pi over 6. So this is going to the right, pi over 6. All right, so let's talk about what a secant is. First of all, in our whole period, secant is the inverse of cosine. Remember, cosine starts up here, goes down, and finishes up here. So it actually crosses in two places, and right here in the middle, it's at its lowest point, right? So actually, let me put, if it was cosine, let me put that on here. It would start up here, cross through, go to the bottom, cross through, and come up. Well, at those points where it crosses through, those, for a secant, would be our asymptotes. Oops, and we would have, sorry about that, we would have one over here. Right? And so when we do secant, it starts in the same place and approaches each of the sides in the reverse order. Okay? So now that we know that's what secant is, here's the whole idea. The period from 0 to pi over 3. We also know that halfway between 0 and pi over 3, right here, is at pi over 6. So halfway between 0 and pi over 6, this is pi over 12. And this one is 3 pi over 12. I had to think about that for a second. Sorry. Alright, so now, this is our case, and this is saying that it is shifting a pi over 6. So right now, we have an asymptote at pi over 12, and we're going to shift to the right pi over 6. So I'm just going to add those together. So I end up with 3 pi over 12, which reduces, of course, to pi over 4. So remember, this is the inverse. It's the zeros of a cosine is where your secant asymptotes are. We didn't discuss this a lot during the year, but we did go over it. Number 52, let's talk about that one. On number 52, they give you a beautiful picture of a graph. Right? In this graph, let's see if I can draw it on here. It comes down, touches the x-axis, goes back up, comes down, kind of crosses through the x-axis, right? Kind of in that form. Kind of, sort of. All right. So first of all, let's count the number of times this turns, right? It turns 1, 2, 3, 4 times. Turns 4. And because it turns 4 times, we know that this has to be to the 5th degree. At the very minimum. Alright. Number 53. On number 53, we have the point xy lies in the third quadrant of an xy plane. So we have x minus y equals 1. And we have x squared plus y squared equals 5. It wants to know what is the value of y that satisfies both of these. So, first of all, let's kind of get a picture of what's happening here. Let's talk about it. This bottom one is a circle with a radius of square root 5. Right? So it has a center of 0, 0, and we're going to say it has a radius of square root 5. We're just going to approximate it kind of like that. Then, which follows anywhere from between 2 and 3, either way. Alright, then this is a line, of course. We know that this crosses at both 1 and negative 1. So it crosses here. Here's our line. Alright, so we're actually looking for, it wants to know what is the value of y that satisfies it in the third quadrant, right? The third quadrant, which means we're looking for this point right here. And I want to know what the y value is. Alright, so let's do it algebraically now that we know what's going on here. We can actually take and use substitution. It would probably be the easiest approach. I'm going to add y to that side. So I have x equals 1 plus y. And I'm going to plug this in for x in this equation. So I have 1 plus y, or y plus 1 squared, plus y squared equals 5. Because I'm looking for the y value, I might as well get rid of x. Now, if I go ahead and put this in here, 1 plus y squared, whoops, and 1 plus y squared, I get 1, I get y squared, I get y squared, and I get y to the 4th. Alright, so now let's see. I have, just with this part, I have 1 plus 2y squared plus y to the 4th equals 5. Okay, I got to combine. Oops, I forgot my y squared has to go in here. My bad. Combining like terms. And I'm going to put it in the right order. I have y to the 4th plus 3y squared. And if I subtract 5 to this side, minus 4 equals 0. Alright, so now I can go ahead and factor this. Negative 4 on top and 3 on the bottom. That gives me a negative sorry, 4 and negative 1. Alright, so where did I go wrong on my math? Let's double check my math here. Alright. Okay, so let's keep going. We have factors. And remember, this is y to the fourth, which means it's going to be a y squared plus 4. And y squared minus 1 equals 0. Alright, so somewhere I made a mistake in my math. We've got to double check this here. When I plug this in, 1 y squared, and y to the fourth, correct? Here, adding my diagonal together. Four. I'm sorry, I found my mistake. So let's back it up. I apologize for that. This right here, when I plug it in, it's only a y, not y squared. So let's back this all the way up to my box. I, again, apologize for that misstep. My bad. Alright, let's talk about this again. First of all, I'm going to plug in 1 plus y squared for the x. And then I have y squared equals 5. When I put this in the box this time, 1 plus y and 1 plus y, I apologize. 1, we get y, and y squared. That's so much better. So we have 1 plus 2y plus y squared equals 5. Now, combining like terms, I have 2y squared plus 2y, subtracting 5 to this side, minus 4 equals 0. So much better. Now we need to factor this. When we factor it, we need to undistribute the greatest common factor first, which is 2. Leaves us with y squared plus y minus 2 equals 0. And then if we go ahead and factor it, negative 2 and 1, we have 2 and negative 1. So we get y plus 2 and y minus 1. So our two options for y are y equals negative 2 and y equals positive 1. Remember, we wanted the one that was in the third quadrant. So in the third quadrant is this one. Sorry about the mistake in the beginning. I apologize for that. So let's talk about 54. On number 54, we have f of x equals x over the absolute value of x. What is the range? So remember, range is always the values you get, right? And no matter what, our range is going to fall between what and what. Or it's going to be what and what. So let's just test them, right? If we say x is 1, we get 1 over 1. If we say x is negative 1, we get negative 1 over 1. If we say x is 2, we get 2 over 2, which equals 1. If we say x is negative 2, we get negative 2 over 2. So no matter what we try, we end up with either 1 or we end up with negative 1. Those are our only two options that are going to come out for y. So when we talk about the range can only be equal to either positive or negative 1. It can't be anything else but those two values. Number 55. On number 55, we have the tangent inverse of 2 cosine pi over 3 equals. So we need to first evaluate inside this parenthesis. So tangent inverse of 2 times, what is the cosine at pi over 3? At pi over 3, the cosine is 1/2. So then really what we want is the tangent inverse at 2 times 1/2 is 1. And tangent is 1 at the square root 2 over 2 over, square root 2 over 2 over the square root of 2 over 2, which occurs at pi over 4. All right, number 56. Number 56, in the xy plane, the graph of, we have y equals x, and x squared minus 2, and x squared plus x plus 1. And it wants to know intersects the x-axis in how many different points. Well, first of all, we know this one gives us a 0 at 0, so x equals 0 here. This one, if I set that equal to 0, if I put this equal to 0, I get x squared equals 2, or x equals plus and minus the square root of 2. This one, the wonderful thing about this one is that it does not factor. So this has no real solutions. So how many real solutions do we have? How many times is it going to cross the x-axis? 1, 2, and 3 times. All right, number 57. On number 57, we have the sine at 2x over sine minus the cosine at 2x over cosine. All right, and we want to simplify this, right? So we're going to start by changing out this double angle formula. So we know for sine 2x is actually the same as 2 sine x cosine x, still over sine x, over sine x minus, now we can change out cosine also. One of the ones for a double angle for cosine, and it wouldn't matter which one you chose to use, is 2 cosine squared x minus 1 over cosine x. All right, so now we need to put these together, okay? In the first one, my sine x's will cancel. So really I just have 2 cosine x. And I need to get a common denominator. So I'm going to multiply this first one by cosine x. So I actually have 2 cosine squared x minus 2 cosine squared x. And don't forget to distribute the negative, plus 1. All over cosine x. So you'll notice 2 cosine squared x minus 2 cosine squared x. Those will cancel. And we're left with 1 over cosine x. And that's it. Number 58. On number 58, you just have to move some stuff around, right? So the first thing is it tells you that at p of 1 it equals 5. So we're going to start with that. I have 5 equals 1 over 1 plus 1 over p minus 1 e to the negative r times I. And again, I is what we're saying is the value of 1. Okay? So I have a e to the negative r. All right. Now let's go ahead and simplify this a little bit. We've talked how we can multiply this to this side and drop 5 to that side. So we can rewrite this as 1 plus 1 over p minus 1 e to the negative r equals 1/5. Alright, so I'm going to subtract 1 from both sides, which gives me 1 over p minus 1 times e to the negative r equals negative 4 over 5. Alright, so technically I need to get e by itself, so I'm going to divide by this. But before I do, let's talk about a better way to write that. We can get a common denominator here and put it all in one fraction, which means I need to multiply this side by p. So I really have 1 minus p all over p. And I'm going to go ahead and divide that to this side. Alright, so what we're left with is we have e to the negative r equals negative 4 over 5 divided by this, which means you're really multiplying by its reciprocal. Alright, so let's rewrite that. We have e to the negative r equals negative 4p over 5 times 1 minus p. We're getting close. We still have this negative r, though. So the next thing we have to do is when you have a negative exponent, what does e do? It moves it to the bottom. So really this is 1 over e to the r. All right, well, if that's the case, then I can cross multiply, right? And I have e to the r times by negative 4p equals 5. Try that again. 5 times 1 minus p. Alright, so I'm going to go ahead and divide by the 4p. So I have e to the r equals 5 times 1 minus p over negative 4p. And last but not least, to get rid of e, we put a natural log in front of both sides. Cancel d. And that's our final answer. Now, there are other ways to get to the same answer. This was my easiest approach, but again, there's other approaches. Talk about number 59. On number 59, we have the cosine of 2x plus 1 equals the sine of 2x. And it wants us to find all solutions on the interval from 0 to 2 pi. So first of all, we need to change it so that they're both the same, right? Or change them so we don't have that double angle in there. Let's start with that. The one we preferred to use before, let's use that one again for cosine, which is 2 cosine squared x minus 1, and then we have plus 1, equals, this one we said was 2 sine x cosine x. Alright, over here, this negative 1 and positive 1, they cancel. So I have 2 cosine squared x. Then I'm going to subtract, this to this side. So I have minus 2 sine x cosine x equals 0. Now what do we have in common in both? We have a 2 and a cosine. So we're going to undistribute that, leaving us with a cosine of x minus the sine of x. Alright, then just like anything else, we're going to use the zero product property. We set each of those equal to 0. 2 cosine x equals 0, and cosine x minus sine x equals 0. For this one, We're going to divide by 2. We just need to know, where does cosine x equal 0? Well, that's easy. That's at the top and the bottom of the unit circle. So pi over 2 and 3 pi over 2. This one's a little bit harder. Because it's cosine x minus sine x, what we're going to do is just move sine x over. So we just need where cosine x is equal to sine x. We need them where they are exactly the same, which is at pi over 4. They are both positive, square root 2 over 2. And at 5 pi over 4, they are both negative, square root 2 over 2. So these are our 4 answers. Number 60. On number 60, we have e to the 2x minus e to the x minus 2 equals 0. Alright, I'm actually going to do a substitution because I think it's going to be easier for you guys to see. I'm going to say that u equals e to the x. So really, I have u squared here minus u minus 2 equals 0. So then we can go ahead and factor that. Negative 2 on top and negative 1 on the bottom means that my factors are negative 2 and positive 1, or u minus 2 and u plus 1 equals 0. So u equals 2 and u equals negative 1. Now we can go and plug those back in. So here I have 2 equals e to the x. And I also have negative 1 equals e to the x. To get rid of e, we use natural log. So this one would be the natural log of 2, right? If I put a natural log in front of both sides, equals x. This one